Social behavior is all around us. It shapes our lives in simple ways and in important ways. I'm Weko, and this series introduces SOCPROG, a popular tool for analyzing social structure. In previous videos, we downloaded SOCPROG, loaded a sample data set, and set sampling period, association rule, and restrictions. In this video, we're going to focus on performing numerical analysis on our associations. First, we load our data. We're going to use a sampling period of day. Association is defined by the group variable line. And we're not going to use any restrictions. Start by choosing to analyze associations. Since we converted our data to linear mode, we cannot analyze interactions. So we select associations. We use the half-weight index and ignore the options at the bottom of the window. Remember that these choices should be made based on the data that you've collected. To learn more, see my video on association indices, check the SOCPROG manual, or review papers associated with these techniques. For now, we're just using common techniques to demonstrate the functionality of SOCPROG. This brings us to the window where we can analyze association indices. We have a lot to get through in this video, so I won't explain each of the techniques in detail, but if you're interested, see my other videos. There are 5 distinct sections in this window. In the upper left, you can see how we've set up the data, and if we want to, we can reset the association index. If you wanted to change the sampling period, association variable, or restrictions, you would have to close out of the analysis window and go back to the set window. This portion of the interface lets us set parameters for the analysis that were initiated below. We will explain these options when it comes time to use them, but for now, let's just leave all of them set to the defaults. On the left, we have a collection of numerical analysis for association matrices. Here we have a collection of visualization techniques, and these are methods for analyzing avoidance or preferences. In this video, we're going to work our way through the numerical analysis. The first thing to do is simply list the association indices. Remember that SOCPROG has 2 windows that are always open. The first is the master screen that we've been using as a graphical user interface, and the second is the command window. The association indices are output to the command window along with some useful header information. Notice that the individual IDs are ranked in alphanumeric order, even though they were originally numerical values. You have got to keep this in mind when you interpret the results, because it would be very easy to mislabel the rows and columns of this matrix. You have a couple options for how SOCPROG estimates standard error. You can use the bootstrap method or make a binomial assumption. In general, I recommend using the bootstrap method. This is because the binomial assumption assumes that association between dyads is independent of other dyads, which is a strange assumption if we think that individuals are affecting each other's behavior. The drawback to using the bootstrap technique is that it is computationally burdensome for large data sets. Anytime you use the bootstrap method, you should think carefully about how many permutations you perform on the data. If you do too many permutations, SOCPROG may take a long time to do the calculations without any real improvement in the accuracy. If you do too few permutations, SOCPROG may estimate the standard error inaccurately. The number of permutations appears in an editable field in the upper right-hand section of the analyzing window. The default is 1,000, and you can make it whatever you want, but you should keep it above 100. If you have a large data set and it takes too long to run the bootstrap, you might use the binomial approximation. Before doing this, I recommend running a test on a subset of the population. Restrict your data to a subset of individual IDs, calculate the association indices, then compare the bootstrap estimate to the binomial approximation. Only if the results are similar should you use the binomial approximation on the full population. There's one other important thing to keep in mind when estimating standard error. Both methods assume that the associations in different sample periods are independent. So you have to really think about your sampling period. If your samples aren't independent, the estimated standard error won't be useful. At this point, SOCPROG does 2 things almost instantaneously. It estimated the standard error and printed it to the command window, and then it prompts us to save the results. Let's look at the results first. As before, we have a header along with our results. Now, SOCPROG is a little inconsistent in how it goes about saving results. Just a second ago, we calculated the association indices themselves, but SOCPROG didn't prompt us to save the results. Here, we have the standard error for the indices, and we do get a prompt. In a second, I'll show you how to save the association indices, but for now, let's finish up with the standard error. You can either save an ASCII file or a MATLAB file. And from here on, it's just like saving any other file. Okay, so how do you save the association indices themselves? Well, you have the same choices of ASCII or MATLAB, but you get to them from the Analyzing Association Indices window. Additionally, you have two more formats that you can save the association index into. These options let you save VNA files, which are used by UCNet and NetDraw, or GraphML files for network analysis programs such as WIAD and Gephi. Now we get to some interesting analytical options. First, you have two options for analyzing the distribution of associations. The first option gives us the distribution of associations for individuals as a list in the command window. SOCPROG gives us the mean association, the sum of associations, and max association for each individual. The second option plots a histogram of the association. There are 4 different qualities that you can plot. The first option is to plot the association indices themselves, but you can also plot the same data that we had in the list, that is the mean, the sum, and the max associations for each individual. You can also switch between bars or symbols, set the number of bins in your histogram, and choose between total and proportion for the y-axis. Once you have a plot, you can add a second set of data. As an example, let's add the mean associations. This next section was developed by Hal Whitehead in conjunction with David Luceau, and it has some of the most useful analysis that you're going to need. There are 5 commonly used measures. An individual's strength is simply the sum of associations minus 1. High strength indicates that an individual has strong associations with others. Strength is closely related to the concept of gregariousness, because gregariousness represents the average number of others an individual is observed with. An individual's eigenvector centrality will be high if the individual has relatively strong associations to other individuals, which in turn have relatively strong associations. An individual's reach is a useful concept in a society that possesses behavioral contagion, so that the behavior of A towards B will influence the behavior of B towards C. An individual's clustering coefficient measures how well the associates of an individual are themselves associated. And finally, an individual's affinity will be high if it has strong associations with individuals who have high strength. As I said before, we're just glossing over the technical details of these methods. See my other videos for more information. This module only handles symmetric association indices or interaction measures. If you're working with asymmetrical results, SOCPROG will ask if you want to cancel the analysis or proceed using the average of the symmetric elements. There are a couple ways you could have ended up in this situation. Obviously, you could have collected data on a directional interaction, but you also could have imported an asymmetric matrix, or you could have a custom association index that produces asymmetric results. Assuming that we're working with a symmetric matrix, pressing Network Analysis Measures gives us a small window with a couple of options. Our first option is to estimate standard errors using the bootstrap method for all the measures calculated in this module. I like this option, and I almost always use it. And remember, the number of permutations that SOCPROG performs is controlled from the Analyzing Association Indices window. You can choose to get output for each individual. For large populations, this can be fairly cluttered, but for now, let's select it. The next option, Controlled Permutation Tests, is experimental. The SOCPROG manual actually has a warning that says, do not use this option unless you think very carefully about what you're doing. I can't guarantee that I've ever thought carefully about anything in my life, so I'm just going to stick with the do not use portion of this advice. The final option is simply to save the results. Our output appears in the command window. First, we have the network measure for each individual along with the estimated standard error in square brackets. Remember that the individuals are in alphanumeric order. Below the individuals, we have the overall means. And at the very bottom are the correlations across individuals of strength with clustering coefficient and strength with affinity. If the strength and affinity of nodes is correlated, then gregarious individuals are preferentially linking to each other, which is known as assortative mixing. Assortative mixing is generally characteristic of social networks. Our next analysis is community detection. First, when we use SOCPROG to do community detection, we have two options, modularity 1 and modularity 2. Modularity 1 is the classic version of Mark Newman's 2004 paper with gregariousness worked into it. As I mentioned before, if you're going to use any of the gregariousness analyses, you should review the paper that it's based on and make sure that this technique is appropriate to your data. When it comes to modularity 2, the SOCPROG manual has a comment that modularity does not work with this method. Let's start by selecting modularity 1. You have an option to save the clusters as supplemental data, but I won't for now. SOCPROG automatically determines how many communities are in the population based on an eigenvector-based method from Mark Newman's 2006 paper. This technique is efficient, but as with so many things, you have to ask if it's right for your data. It's interesting to note that these two methods give different communities for the same data. So my recommendation is that if you're going to publish a paper that detects communities, use a different piece of software. This analysis should be used for exploratory purposes only. Okay, in this video, I have glossed over a ton of different techniques. And I've taken it for granted that you understand the theory and assumptions that are associated with each technique. But if you want to learn more, I have videos to help enrich your understanding.